Out in the world, if you're a kid learning, you really like to learn by playing with stuff, right? We throw balls around when we're toddlers, we catch things, we pour sand back from one bucket to another, we learn how sand works. But in algebra, we expect students to play with the algebraic representations and remember all the rules that instantiate the world. So Graspable math is a way to let the algebra respond to us, to let us play with the algebra.
Graspable math turns algebra into something like a real thing you can interact with. And that's something fantastic for students, which can actually now go and explore algebra.
Graspable math for the student and the teacher is a way to pick up the symbols and move fluidly.
So we can see Graspable math being used as a teacher presentation tool where a teacher is standing in front of a smart board or a projector and explaining things more clearly to the classroom.
This sidebar that lets you pull in equations from Wikipedia or a lot of other sites.
A homework tool where students get immediate step-by-step feedback.
Graspable math came specifically out of a Department of Education funded project to develop interventions that would help students see the dynamic properties of algebra, see this dynamic algebra the way that experts do. And we're working with schools in Massachusetts, in Virginia, in Indianapolis to study how kids learn. And our commitment is to make sure that it's always free for teachers and students.
So the state of the art in algebra assessments is that you give students a problem and then they type in the final answer.
Often we say, okay, well, the student got the problem, check.
But they're still doing all their algebra with pencil and paper.
What we can get is a very different insight into how students are succeeding.
In Graspable math, students really trigger each algebraic step by a gesture. They really control how they go through a derivation. And Graspable math will record all of these steps.
In a usual experimental context, all you get is the answer the student gives, or you have to hand code all the steps that they did. But we get everything the student did and everything the student tried to do and failed. So we can find out what kinds of things students think are a good idea as they're struggling to learn these algebraic concepts.
The student can look at them, the teacher can look at the steps. You can compare different ways of solving a problem.
And that gives us, I think, a unique access to misconceptions students have and to struggles that students have, and then just to ways that they succeed.
There's certain types of mistakes you can still make in the system, which are the strategic mistakes, which are going off in the wrong direction without breaking the rules of math. These kind of mistakes are incredibly important for learning, and you can still make them in our system.
One way that it gets used is for research, and then the other place it gets used is by teachers who just find it.
It ensures that you play by the rules and creates this safe space.
Graspable math helps support whatever algebra a teacher's teaching.